Today, we're going to cover one of the most basic yet most commonly mistaken topics in TIG welding: choosing the right tungsten electrode. The wrong tungsten can cause an unstable arc, reduce penetration, a poor weld bead, and shorten the electrode's lifespan. But when the right tungsten is selected, you'll get a more stable arc, a cleaner weld bead, and a more professional result. In this video, I'll walk you through the 10 most important factors to consider when selecting a tungsten electrode for TIG welding. In TIG welding, the tungsten electrode is the key component that carries the current and creates the arc. Tungsten, with a melting point of approximately 6,190 degrees Fahrenheit, has the highest melting temperature of all metals. This allows it to withstand high heat, maintain its shape without deforming easily, and provide a precise, controlled arc. The foundation of what makes TIG welding so clean is this very tungsten electrode. Not all tungstens are the same. Its behavior changes completely depending on the alloy it contains. The most common types of tungsten are pure tungsten, thoriated, ceriated, lanthanated, and zirconiated. Making a choice without knowing these differences puts the weld at risk right from the start. Tungstens are color-coded according to the AWS standard. These colors help you quickly understand which one is suitable for which job. Green pure tungsten is ideal for alternating current welding. Red 2% thoriated is perfect for direct current welding. Gray 2% ceriated is best suited for low amperage and delicate welding applications. Yellow 1% lanthanated. In direct current welding, it provides a stable arc, easy arc starting, and precise heat control. Blue 2% lanthanated is very versatile. It performs well with both alternating and direct current. White 1% zirconiated is widely used in alternating current welding due to its high arc stability and durability. Knowing the color codes prevents the use of the wrong tungsten. The material being welded is the most decisive factor in tungsten selection. General use: for aluminum and magnesium, green or white; for carbon steel and stainless steel, red or blue; for thin sheet metal and delicate jobs, gray or yellow. A tungsten that doesn't match the material will cause problems no matter how well you adjust your settings. The type of current used in TIG welding directly affects the tungsten's behavior. Direct current, electrode negative. For steel, stainless steel, and titanium, it provides a narrower arc and deeper penetration. Alternating current. For aluminum and magnesium, it provides an oxide cleaning effect and surface cleaning. The wrong current plus the wrong tungsten equals an inevitable mistake. Tungsten diameter determines the current carrying capacity and arc stability. 1/32 to 1/16 of an inch, thin materials, low amperage. 3/32 to 1/8 of an inch, thick materials, high amperage. A very thin tungsten will burn up at high amperage. A very thick tungsten creates an unstable arc at low amperage. The shape of the tungsten tip determines the character of the arc. A pointed tip, direct current welding; a narrow focused arc, deep penetration. A rounded tip, alternating current welding; a wide arc, and an oxide cleaning action. Remember, if the tip shape changes, the arc changes completely. For precision work, gray or yellow tungsten provides a much more stable and soft arc. For high amperage jobs, red or blue tungsten offers more powerful performance. This means not every tungsten is suitable for every job. Thoriated tungstens contain a small amount of radioactive thorium. Therefore, wear a mask when grinding them. Work in a well-ventilated area. For those seeking a safer alternative, lanthanated or ceriated tungstens are both high-performance and risk-free options. Cheap and low-quality tungsten means rapid contamination, an unstable arc, and a short lifespan. Buy tungstens from reputable brands and store them in a sealed container. Keep them away from moisture. Moist tungsten equals an unstable arc. Remember, the right tungsten equals a stable arc, the right choice equals a clean weld, and the wrong tungsten equals constant problems. And that's our guide on how the correct tungsten electrode selection in TIG welding directly affects arc stability, penetration, and weld quality. If you found this video helpful, don't forget to like it and subscribe to the channel for more TIG welding tutorials. See you in the next video.